Let f of x be defined as the piecewise defined function 2x minus 5 whenever x is less than or equal to 3, and negative 7x plus b if x is greater than 3. If f of x is a function which is continuous everywhere, then we must have b equal to what value? So at this point, b can take on a lot of numbers. It could potentially be any value in the range from negative infinity to positive infinity. And this symbol that looks like a funny looking E is just saying B is an element of this particular set. So it can take on any number at this point. So we want to figure out a way that we can restrict the number of values and possibly determine some method of figuring out exactly what value is going to work. One thing that's going to be really important for us to understand is the rule y equals f of x still applies even when we are dealing with piecewise defined functions. So whenever we choose some value of x, we put that into the function f of x, what we're going to get is some output value, which could look like, I'll call this y1 just being the first piece and y2 being the second piece. So it really could look like x comma y1 of x if x is less than or equal to 3, or it could be x comma y2 of x if x is greater than 3. But there's still x values and y values. Now, at this point, you should probably be fairly comfortable with graphing a piecewise defined function. If you're not, then you're going to need to review that. But assuming that you're okay with that, let me bring up something that will help us visualize what we need to do. So here is a graph of our piecewise defined function. 2x minus 5, that's the first piece, is graphed here in blue. So this line here has a y-intercept of negative 5, though it goes off screen and you can't see it, but that's okay. And it has a slope of positive 2. So when we go from this point to the next point, well, let's say from this one. So from x equals 1 to x equals 2, I'm going up 2 values and across 1. It looks a little bit strange because these sub-markings are every half interval, but that's what's happening. So slope of 2. Now, it is also defined only on the values where x is less than or equal to 3. So along this interval right here, we have x less than or equal to 3, and I've included the point at 3. The other part's a little bit more difficult to graph because b is a variable. B can take on different values. But I've set this up to where I can change the value of b and observe what the graph is going to look like. So it's always going to be a line with a slope of negative 7. That's a constant. The only thing that could potentially change is the value of b. And there's only one value of b that's going to make a continuous curve here, because in order to have continuity with a piecewise defined function, you have to have the graph approaching the same y value on the left as it is on the right. So in order to make that happen, we need to determine where this point is. So let me move my value of b here. So I want to know where this point is in the blue. So in order to determine where that point is in the blue, I'm going to come over here, and I know it's where x is 3. So I'm going to let x equals 3, and then I'm going to plug that into f of x. So that's my x value. F of that is going to be 2 times 3 minus 5, which is 6 minus 5, or 1. So that particular point has the coordinates 3, 1. And that is a constant. That's always going to be the same. What we want is the graph that's in green to also contain the point 3, 1. So if it also starts at the point 3, 1, then we will have a continuous function. Let's see how we can make that happen. So uh, the x value is going to be 3, but what we want is the y value to be 1 for the function negative 7x plus b. Now remember, this right here is a y value. So the output of any function is a y value. I have an x and I have a y, 3 and 1. So I'm going to plug those in, say negative 7 times 3 plus b equals 1. So this is negative 21 plus b equal 1. Then if I add 21 to both sides, it allows me to solve for b. So b has to be the value 22 in order to make this continuous. And that's exactly what we saw in our diagram, because if you look up here where it tells you what the value of b is currently, when it is 22, those two curves are matching up.